Okay, here we're going to talk about the various ways to measure angles. And there are two main units which we use. Spoiler alert, those are going to be radians and degrees. We will be using both of them. Certain scenarios call for one over another in some situations, but in most situations either are valid measures. Okay, so what are the two units of measure used for angles? Well, we just said it. We have degrees, which we should hopefully be pretty familiar with. And then we also have radians, which we may not be as familiar with. So I want you to take a second, and we're going to discuss both of these in length here, but I want you to try and recall what is the equation for the circumference of a circle, and in geometry, what did you learn is the relationship between a central angle and its arc length. So I want you to pause the video and think about that. If you don't remember them, look it up on Google, or look it up in your book, whatever you want. But pause the video and find those. Okay, so hopefully you remembered or found that the equation for the circumference of a circle is circumference equals pi d, where d is the diameter, or circumference equals 2 pi r, where r is the radius. And this is the version that we're going to focus on for now, because notice if I rearrange this, so let's say we divide both sides by r, we end up with c over r equals 2 pi. Where again this is the circumference and this is the radius, and this we're going to come back to in a second. So what did we learn the relationship is between a central angle and its arc length? Well, the central angle, if it's in degrees, is equal to the arc length in degrees. That's what we learned. So here's our little picture. It's not perfect. There's a circle, there's a radius. So if I have this central angle, then this arc length is the same as that central angle. Notice that both of these, though, are in degrees. Okay, so since both of these, the central angle and the arc length, have to be in degrees, for that property to hold true, let's go back up here. So here again, look at C, which is circumference, which technically the circumference is an arc length. It's just the entire arc length of a circle. And r is the radius equals 2 pi. None of these are in degrees. So what is this? Well, this is actually radians. And specifically, the 2 pi is an angle measure in radians. And this leads us to the definition of a radian, and that is this. So this I just copy and pasted again from your packet, so it's in there. 1 radian is the measure of a central angle of a circle, theta, so that's the angle measure, that intercepts an arc, s, so s is an arc length, theta that intercepts an arc s equal in length to the radius r of the circle. So what does that mean? That means that if the arc length is the same as the radius, then the central angle is 1. That's going to be 1 radian. So theta equals s over r tells us how we can find the central angle in radians. We take the arc length and we divide it by the radius. So if s and r are equal, then you have 1 radian. It doesn't have to be equal. And so now with this idea, and thinking about this equation right here, because remember the circumference is also an arc length, if we have the entire circle, so C is my arc length and R is my radius, what is the central angle in radians? We have 2 2 pi radians. So how many degrees are in a circle? Hopefully you're writing down. (360). So we have 360 degrees in a circle. We have 2 pi radians in a circle. So what does that tell us? That means that 360 degrees equals 2 pi radians. Also, another thing to note, radians does not have any sort of symbol to denote radians, whereas degrees has that little degree symbol. So anytime that you see an angle measure and it does not have the degree symbol, you have to assume it's radians unless you're told otherwise. Okay, now I want you to take a minute and answer the next few questions on your own. So if you know that there are 2 pi radians in one revolution of a circle, how many whole radians are there in a revolution of a circle? So this is whole numbers. 2 pi is not a whole number because pi is an irrational number. So I want you to think about that. Then the next one, how many degrees are in one revolution of a circle? Spoiler alert, we just talked about that. And which is bigger, 1 radian or 1 degree? And then I want you to approximate how much bigger. So pause the video, answer those questions, and unpause when you are ready to discuss. Okay, well, if I know that there are 2 pi radians is the central angle of a circle, or 1 revolution of a circle, I know pi is approximately 3.14 as a decimal or number, and 2 pi then would be approximately 6.28, so there would be 6 whole radians in a circle. There are more than 6 radians in a circle, but as far as whole numbers, not total radians, I would say 6. How many degrees are in one revolution of a circle? 360 degrees. So which is going to be bigger, 1 radian or 1 degree? Well, if there are 360 degrees in a circle and a little bit more than 6 radians in a circle, then 1 radian has to be much larger than 1 degree. Approximately how much larger? Well, it's almost 60 times larger. It's actually going to be 57 point something. How can I figure that out? Well, to get the 60, I can do a rough approximation of the fact that I know there are 360 degrees in one circle, and I know there are about 6 radians in one circle. So if you do 360 over 6, you are going to get 60. Now I know it's actually a little bit more than 6 because it's actually 2 pi. So if you do 360 degrees divided by 2 pi, then that's how you're going to get 57 point something. But again, it's just to give us a relationship between radians and degrees. Okay, so then this leads us to the next thing, converting. How do we convert from radians to degrees and degrees to radians? Well, we use this relationship here that I know there are 360 degrees in 2 pi radians, or 2 pi radians in 360 degrees. I can reduce that though, and I can say that there are pi radians in 180 degrees, or 180 degrees equals pi radians. So to convert from degrees to radians, I multiply the degrees by pi over 180. If you've taken chemistry and done factor labeling, that's really all we're doing, is you're taking what you have, which is degrees, and multiplying it by what you want, which is radians, and dividing by the degrees. So I want you to convert the following degrees to radians. We are going to both leave these as exact values reduced, and we are going to round to 3 decimal places. Okay, so we'll do the first one together here. So if I do 45 times pi over 180, I know that I'm going to do first the exact values. So 45 goes into 180 4 times, so this becomes pi over 4. So 45 degrees is the same as pi fourths radians. If I want to type this into my calculator, I can do 45 times pi over 180 and hit enter, and I get 0.785 radians. So that's to 3 decimal places. So we want to do both exact answers, reduced, and round to 3 decimal places. Pause the video, do the rest of those, unpause when you are ready to check your work. Okay, so for 70 degrees, I do 70 times pi over 180, which reduces to 7 pi over 18. Type that into my calculator and I get approximately 1.222 radians. So both of those are radian measures. Also, when you're doing this, especially typing in your calculator, make sure the answer makes sense. So remember, we just talked about briefly that 60 degrees is slightly more than 1 radian. So 70 degrees should be a little bit more than 1 radian. 180 degrees is pi, which is approximately 3.142. 585 degrees, notice this is larger than 360 degrees. That's okay. We're going to get into that later, but you can have angles that are infinitely large. You can also have negative angles. We'll talk about that in a minute. But I multiply by pi over 180 and I get 13 pi over 4. So it's 13 pi fourths radians, or 10.210 radians. 301 degrees, this does not reduce, so in radians it's 301 pi over 180, or 5.253 radians. Converting the other way, so if we have radians and we want to go to degrees, again, same thing, but now we're going to flip what we multiply by. So I take the radians, I multiply by what I want, and divide by what I have. We're going to do the same thing. We're going to do both exact values, reduced, and round to 3 decimal places. So if I convert 1 radian into degrees as an exact value, this would be times 180 over pi, which is 180 over pi. If I go to my calculator and I type in I get 57.296 degrees. Okay, so I want you to go ahead and convert the rest of these. Pause the video, unpause when you're ready to check your work. Alright, for the next one, 3 pi fourths radians, if I multiply by 180 over pi, I get 135 degrees. Exactly. So I don't need to round to 3 decimal places. It would be 135 degrees, 0.000. 60 radians times 180 over pi is 10,800 over pi degrees as an exact value, or 3,437.747 degrees. 16 pi thirds also comes out to be a whole number, so 960 degrees. And 24 pi thirteenths is 4,320 over 13 degrees, or 332.308 degrees. So here it's really important that we understand the relationship between radians and degrees is that 2 pi radians is 360 degrees, or pi radians is 180 degrees. That's how we do our conversions back and forth. Okay, so now we're going to use our definition of radians. So if you're given an arc length of 25 feet and a radius of 17 feet, I want you to find the central angle in both radians and degrees. So use that arc length equation that we looked at earlier for the definition of radians, and it's in your packet. Pause the video, find the central angle in both radians and degrees, unpause when you are ready to discuss your answers. Alright, so here we use our arc length equation, the central angle, which is in radians. So whenever you're using this equation, this angle has to be in radians. If you were given an angle in degrees, you need to convert it to radians before you can use this equation. And if you're solving for the angle, you need to understand your angle will be in radians. So if I do S over R, it's 25 over 17. That's an acceptable answer. So I have 25/17 radians. If I want to type it in my calculator, round to 3 decimal places, I get 1.471. Convert that to degrees, multiply by 180 over pi, and I get 4,500 over 17 pi degrees, or approximately 84.258 degrees. Okay, so we're running out of time on this video, so you're going to have to go on to part 2. There's a few more topics we have to discuss, positive and negative angles, as well as complementary and supplementary angles. So we're done with part 1.